lot of material, right? You already got a little taste. We got a lot of material we're going to cover this weekend. And I know a lot of it is going to be probably new to you, which makes it a little bit more difficult to stay with me and grasp it. So hopefully you're being able to use this. Hopefully this is useful to you to kind of help you stay focused. I'll be trying to break down, I use a lot of quotes because I want you to see with your own eyes what they are saying, not just take my word for it. Because that was something that bothered me as a kid. I wanted to see what they were actually saying. And I intentionally picked big name people. So I'm going to have a lot of quotes, but they can tend to be a little more sophisticated jargon. And so I'll try to break it down for you, make it easier for you to understand these quotes. All right, so one more session tonight, and then tomorrow is a heavy day. It'll be 5 sessions, so be sure to get a good rest tonight. You have a good breakfast in the morning, and I'll try to do the same. I guess I got to stand up here the whole time, right? At least at Bear Valley, Dylan, I could sit at my desk. It was not a... All right, so again, we have this origin model comparison chart. And we're going to start going down this chart and dealing with these in turn. And so tonight we're going to look at the first one, and then maybe there'll be implications on the second one as well. But the first one is our main thing that we're going to look at in this session. And so again, we'll keep coming back to this chart as we plow through this weekend. All right. So the first item on the evolutionary chart is the origin of the universe itself. Where did it come from? Most naturalists today argue that cosmic evolution started with the Big Bang. And so let's look at that theory first. According to the currently popular form of the Big Bang theory, and you got to keep in mind that it is constantly in flux, but the currently popular form that's accepted by probably most people, 13.7 or 13.8 billion years ago, the universe originally was basically crammed into an infinitely dense and hot ball that rapidly expanded, kind of like a balloon. And so the idea is that the stars themselves, you have to picture, kind of imagine a balloon with the stars maybe taped on the balloon, and then as you blow the balloon up, the stars don't really move relative to the balloon, but they still move away from each other because the balloon expanding between them. And so that's kind of the idea of what they would say is going on in the universe. But within the first speck of a second, you had something weird go on. This period of rapid expansion that they call inflation, where you've got this period where the universe is expanding faster than the speed of light, with particles forming in the first few seconds. Now again, this is different from just expansion that you'll hear them talking about that's going on today. That's different. Inflation is this special event that is only at the beginning of the Big Bang for just a moment as the universe expands really fast. Atoms come around, say 380,000 years after the beginning. The first stars begin forming after about 300 million years. The first mature galaxies begin forming after about 1 billion years. Our solar system comes around after about 9 billion years, and then Earth is 4.5 billion years ago, with life coming into existence 3.8 billion years ago, and then Darwinian evolution beginning and taking off. Dinosaurs come into existence and go extinct 65, 66 million years ago. The genus Homo, that includes humans, comes onto the scene about 2 million years ago, and so forth. So the first briefly big question is, can you fit the Big Bang with Scripture? No, for several of the same reasons we already saw in the last session, but quickly, Exodus 20:11 says that the heavens, the earth, and everything in them, again, were created in 6 days. The Big Bang model requires billions of years. Number 2, again, New Testament individuals like Jesus and Paul indicated that man was around at the beginning, but the Big Bang requires that he didn't come around till the end. Number 3, the biblical genealogies in Genesis 5 and 11 don't allow for the deep time that's required for billions of years that's required by the Big Bang. And number 4, the chronology of events in the Bible don't match up to the Big Bang chronology. So for example, the biblical model has space, water, and the earth being created first, and the stars, including our sun, not arriving until day 4. The Big Bang model has the earth coming around billions of years after the stars show up. The Big Bang model has the sun coming long before the plants rather than the day after the plants. The Big Bang has the earth initially molten. The biblical model would say the earth was initially covered with or possibly made of water. The Big Bang says fish came before fruit trees. The opposite is the case with the Bible. And so lots of issues like that. So the Big Bang and the Bible just can't be harmonized. Again, it's either or. So what about the Big Bang? Is there evidence to prove the Big Bang, or is it a blind faith on the part of the naturalists? There are 2 main lines of evidences that are typically given for the Big Bang. And the first is that the universe appears to be expanding. So if you've ever noticed how the sound of a train, what a train sounds like as the train is coming towards you, he blows his horn and you hear that pitch change. You hear that pitch change. And that is the Doppler effect. And in a similar way, cosmologists will study wavelengths of light and radiation and determine what are called redshift values, and they use Hubble's law, and they do all this, try to figure out how far away a star is and its velocity. And so from this information, they believe that there's solid evidence that the universe appears to be expanding. Everything is moving away from each other from some central point. And so logically, if you extrapolate backwards in time and you don't have the constraints of a young universe that the Bible portrays, then you're eventually going to reach a point billions of years ago where the universe began all in one place, hence the Big Bang. And so they would argue this is an evidence of the Big Bang. Well, there's problems with using expansion as solid proof of the Big Bang. First of all, we have to keep in mind that expansion might not actually be happening, because there's different ways to interpret the evidence. The deduction that the universe is expanding is based on assumptions which may not actually be correct. And there is some evidence that suggests that might be the case, at least not the expansion they're talking about. So the evidence could be pointing to something totally different than what they're suggesting. But that said, even if expansion were true, in the evidence, I would say, suggests that it might be, it still wouldn't prove the Big Bang necessarily follows, because it's really not a problem even with the creation model. Einstein believed in expansion, but he was more than hesitant to subscribe to the Big Bang. To say the least, he called the whole theory abominable. So the idea of expansion may be even alluded to in the Bible. That may be what's being talked about, for example, in Isaiah 40:22 and these other passages. The Hebrew word that is translated stretches out in Isaiah 40:22, that God stretches out the heavens like a curtain. According to Hebrew scholars, that indicates a state of continued activity, which would mean that that stretching was continuing to be going on in Isaiah's day and presumably today too. Isaiah compares God's activity in the heavens to that of spreading out a tent to dwell in and stretching out a curtain. Again, cosmologists would describe expansion more like blowing up a balloon, but a very similar concept to setting up a tent. Now, a second evidence for the Big Bang is what is called the cosmic microwave background radiation, or the CMB. Satellites have been taking measurements in space that indicate that radiation permeates the universe, permeates space uniformly at 2.7 Kelvin. The CMB was predicted by cosmologists to exist as a result of activity that occurred, they would say, in the early stages of the Big Bang. Although they were way off in the details of their predictions, which means their prediction wasn't actually verified, it was falsified. But still, they were excited because at least radiation was found to exist, and they had predicted at least that. And so they quickly went to work making adjustments to their theory to make it match the actual observable evidence. Now, looking more closely at this uniform radiation found in space, it's a curiosity. The universe-wide uniform temperature of the radiation has long been understood to be a major problem for the Big Bang theory. It's called the horizon problem. And so I'm going to get technical for just a moment here, but try to follow me. So if you've got all these points in space, that are the same temperature, okay, all over the place. The only way for them to get that way is if they exchanged energy with each other until they reached thermal equilibrium, where all their temperatures are uniform. Okay, so how could stars, for example, that are separated by, say, 20 billion light years, have exactly equal temperatures? Because if the Big Bang is true, the universe isn't even 20 billion years old. Since the energy transfer could only be at the speed of light at most, then there simply wouldn't be enough time for all of the universe to have gotten to this uniform temperature if there hasn't been enough time for the universe to exchange the energy. And so this would seem to demand a designer and falsify the Big Bang idea. And then there's also what is called the flatness problem. So if the universe is as old as they say it is in the Big Bang, when you look at the type of energy in the universe and you get a ratio of what's called gravitational potential energy and the kinetic energy, and you look at a ratio of that, it should be, according to the Big Bang idea, either zero or enormous. And yet it's estimated to be close to the number 1. Okay, and they don't understand why this would be. That would seem again to demand a designer or a young universe. So how do they deal with the flatness problem and the horizon problem? Enter inflation. This is the idea that the universe, again, inflated faster than the speed of light for a speck, right, when the Big Bang started, allowing for all the parts of the universe to have been touching and reaching thermal equilibrium at the beginning, which would theoretically cure the horizon problem, and allow inflation to drive that ratio to be close to 1 at the beginning, theoretically curing the flatness problem. So inflation was literally invented to try to fix these two problems so that the Big Bang didn't collapse. Okay, and so this was, these horizon and flatness problems result, remember, from the observation that the CMB exists. All right, well, there's a few things we could say about the CMB that shows it's not evidence for the Big Bang, but it gets technical really quick. But suffice it to say, it doesn't demand, again, that the Big Bang is true. It would be predicted to exist if the Big Bang were true, but it would also be predicted to exist from other phenomena instead of the Big Bang, and in fact, creationists have our own perspective on it. But the big question, though, comes down to inflation, which is that fundamental component of the Big Bang that they made up to fix the horizon and flatness problems, which had to do with the CMB. So is inflation true? That's the question. If it's not, then the whole Big Bang model collapses. And those two Big Bang problems aren't solved. The primary problem with cosmic inflation is that it absolutely has no proof. Remember the law of rationality. One should only draw conclusions that are supported by the evidence. There is no evidence. Inflation is a blind faith. It's not science, and it shouldn't be taught as such. Well, someone says, well, what about the media hype that happened, this is about 8 years ago now, that they thought they had discovered Big Bang gravitational waves that are thought to have been left over from inflation. They thought, we finally have proof of inflation. Well, first of all, understand that there's two different stories that have to do with gravitational waves, which can cause some confusion if you stay up with the science magazines. In 2016, scientists apparently discovered what they think is gravitational waves thought to have been generated by the collision of two black holes, and so there's been lots of stories about that kind of thing. That has nothing to do with the Big Bang. But in 2014, the claim was they thought they had found gravitational waves that were generated from the actual inflation at the beginning of the Big Bang. And so Big Bang, inflation, gravitational waves. And the claim was, hey, we finally have proof of inflation. It's no longer a blind faith anymore, right? And so you see all these headlines, theory no more, and Big Bang smoking gun confirms the early universe's exponential growth. And space ripples reveal Big Bang smoking gun. All right, so the media had the Big Bang as conclusively proven. Well, within 3 months of the supposed discovery of the gravitational waves, the major science magazines began backing away from the discovery. By October, Nature magazine, New Scientist, Scientific American, American Scientist, and Science magazine had all but thrown the discovery under the bus, arguing that the team that made the discovery was probably just seeing the effects of local dust, but they were still courting the possibility it could be true. And then in January of 2015, Nature came out with an article titled, "Gravitational Waves Discovery Now Officially Dead. Combined data from South Pole Experiment, BICEP 2, and Planck probe point to galactic dust as confounding signals." So bottom line is, there is no evidence, zero, for inflation, although it is necessary to fix the flatness and horizon problems which are needed for the Big Bang to be true. And really the problem is worse than that, because even if inflation is true, though it would theoretically cure those two problems, it creates other problems. Questions like, what in the world would cause inflation and what would stop it? They don't have an answer to that too. So the evidences that are brought forth to prove the Big Bang are riddled with issues, anomalies that run counter to the possibility of universal expansion. You got your horizon and flatness problems leading to inventing inflation, which has no evidence for it. And so the Big Bang is not warranted by the available evidence, making belief in it irrational. One should only draw those conclusions warranted by the evidence. The model fails to make accurate predictions and constantly has to be revised and updated ad hoc to stay in line with the evidence. Besides the inflation fiasco, the latest issue has been the images that have been pouring in from the James Webb telescope over the last few months. Raise your hand if you've heard about those. I'm just curious. Okay, a few of you have been hearing about those. Many mature galaxies are being found that, again, based on the standard Big Bang model, shouldn't yet exist if the Big Bang is true. So it falsifies Big Bang predictions. And you've got other problems. The Big Bang hinges on what's known as the cosmological principle, and this is the idea that the universe is uniform and homogeneous. It's spread out, so to speak, and the Big Bang doesn't work without that assumption. The problem is, you look at the actual evidence again, you find out the universe isn't uniform and homogeneous. There are stars and galaxies and clusters of galaxies and so forth that will cluster and make it clumpy. And so it causes this assumption not to be accurate. So it is not really smooth. And there's no good explanation for this in the Big Bang cosmology. The best they do is, well, if you zoom out far enough, it looks smooth. That's their answer to it. But not when you get in and actually look at it close. It's not smooth. It's a big problem. Again, not a problem for the creation model, but it's a problem for their model. All right, another problem, the missing antimatter. Energy can be transformed into matter according to the first law of thermodynamics, but when that happens in the laboratory, an equal amount of antimatter is created. This is basically normal matter that has a reverse charge on its particles. And so an equal amount of antimatter is always produced without exception, according to the actual laboratory evidence. So if the Big Bang is true and energy was transformed into all the matter of the universe at the beginning, then there should have been an equal amount of matter and antimatter, which then would have touched and annihilated each other, releasing their energy. Obviously that didn't happen, if they're right. The universe is virtually completely composed of regular matter. So this is a significant problem. So again, if you stick with the actual physical evidence that you can go into the laboratory and test, you see that the Big Bang model can't be true. Then there's what's called the Fermi paradox. If the universe is as old as the Big Bang theory suggests, where is everybody else out there? With so many billions of stars and even more planets out there, there should be other planets where the conditions were right for life to evolve there too, and in fact long before life evolved on our planet. So they should have long ago colonized our area of the universe, right? So Star Trek, really plays off of this idea. And so where are they? It's as though the Earth is special, the only planet upon which life exists, which is, of course, exactly what we would say. There's so much more I could talk about this, because there's a principle called the anthropic principle, where the leading cosmologists are saying there's only life on Earth and everything seems to be perfect in the universe just for life on Earth. And this is atheists saying this. And so they say, and they'll even tell you all these complicated things of why that proves the Earth has to be very special The whole universe seems to be just for humans. The atheists are figuring this out. And the response to that is, I guess there must be a multiverse. There's no evidence for a multiverse, but the idea is, if there's a multiverse, if there's an infinite number of universes, and we just happen to be there'll be one that's just right for us, and we happen to be in that. That's the idea. But there's no evidence for the multiverse. So we're back to blind faith. And they literally are well, it was the comic books that invented the multiverse, and it's now actually becoming mainstream in cosmology, as crazy as that is. But they literally are wanting to accept the multiverse because of the God problem. They're not even trying to hide it. They all cite this guy. I'm going off too far on this, but they cite this guy that's a professor in England, and he said, if you don't want God, you'd better have a multiverse. And all the cosmologists cite him, and they're all accepting the multiverse, even though there's no evidence for it, because the universe is too perfect for us. Anyway, that's another topic. I could do a whole session on that, but let's move on. There's what I call dark fudge factors. Sometimes in science, in engineering, for example, you'll develop an equation that will describe the motion of something maybe, and it works pretty well, but it's not perfect. Your answer's off just a little bit, and so you add a little fudge factor, and ta-da, it works, right? And the equations all work right. And so it generally means that your equations are missing something in describing reality. It may be really complicated, though, and so it's not very much necessarily, and so your fudge factor can be added, and it's not a big deal. And that can be fine. Now here's the problem. Back in the 70s, cosmologists started seeing some major problems with the Big Bang model that were coming to light based on the actual observations of the universe. And they were becoming acknowledged in a widespread way in the cosmology community. In order to fix the problems without scrapping their models, cosmologists essentially started adding huge fudge factors. And the fudge factors came to be known as dark matter and dark energy. Have you heard of these terms? And now at the time these concepts were added to, this makes it look so much more yummy though, doesn't it? Makes it look more palatable, right? Now at the time these concepts were added to the models in order for the modern theories to make sense of the physical universe. 50% of the universe had to be made up of this dark stuff, even though nobody's ever witnessed them, knows nothing about them, don't even know if they actually exist. But in order for their model to work, they had to add basically a 50% fudge factor. Now, time went by. We've learned more about the universe. You think the problem's gotten better? Almost every issue of some of the popular science magazines that are coming out today mention something about dark matter or dark energy and how nobody's observed these and probably never will, and everybody's trying to hunt for this stuff and what a problem this is. So guess what they're now saying these fudge factors have to be in order to make sense of the universe out there? About 96%. Talking about a fudge factor. Cosmologists claim that 96% of the universe has to be made up of stuff nobody even knows is there for sure. It's unobserved, apparently unobservable. There's no actual evidence of it. So how can this be called science? Now, at least in the case of dark matter, we see some indirect observational evidence that suggests maybe there is some unknown thing that we can't see that's affecting things, but we don't know for sure. And its existence, again, wouldn't even really affect whether or not the Big Bang is true. But dark energy, on the other hand, is needed in order for the Big Bang model to work. And ironically, other cosmological models are available that eliminate the need for that particular dark, but they're largely ignored because everybody is staunchly believing in the Big Bang model. Of course, the creation model is not even on the table. Dark energy is thought to make up, of that 96%, it's 73% of the universe in order for the Big Bang model to work. USA Today reported back in August of 2009 that some secular scientists had discovered a way to eliminate the need for dark energy in their Big Bang equations. Dan Vergano said, mathematicians have come up with an answer Monday for the mystery of dark energy, tearing the universe apart at an accelerating rate. Okay, what's your answer? It ain't there, right? Vergano quoted Lawrence Krauss, who's a well-known theoretical physicist and cosmologist at Arizona State University in Tempe. The only problem is that for the equations to work, we must be literally at the center of the universe, which is to say, the least unusual, says physicist Lawrence Krauss. I think this is plausible mathematics, but it doesn't seem physically relevant, all right? So the math works for this model, but it simply can't be that the Earth is what? In the center of the universe. That would make the Earth seem kind of special, which goes against the Copernican principle, which is, again, one of their big assumptions, that the Earth is not special, it's not in a special favored place. That seems too design-like, too religious. And so they just ignore the model and just stick with this enormous fudge factor instead, just a blind faith. Another model proposed in 2008 suggested similarly that the Earth may be centered in the universe, which would eliminate the need for dark energy. Ron Cowan of Science News discussed the work of theoretical physicist and cosmologist Robert Caldwell of Dartmouth University and theoretical astrophysicist Albert Stebbins of the Fermi National Accelerator Lab in Illinois, explaining that if Earth and its environs are centered in a vast billion light year long bubble, relatively free of matter, in turn surrounded by a massive dense shell of material, then gravity's tug would cause galaxies inside the void to hurtle toward the spherical concentration of mass. That process would mimic the action of dark energy. Let me explain that for a moment. The only observation that is making them say dark energy must exist is this. Let me explain to you. It's not complicated. When we look out there at the stars, almost all of them, because of their redshift values, appear to be moving away from us. Okay, so that's one of the reasons it makes it look like there's expansion going. But it's more than that they're moving away from us, they're accelerating. Now, you can't have acceleration without some kind of, okay, you got a couple different ways you can do it. You either have to have some force pushing it, or you have to have gravity pulling it. Okay, so they've gone with the force pushing it, and they call it dark energy. Some mysterious dark, we don't really know why it's accelerating. There just must be some energy out there. We'll call it dark energy. Moving on. You know, that's what they do. So these guys said, well, what if there's actually this shell of material that's causing gravity to pull these things towards it, and that would cause it to accelerate as well? Which, by the way, creationists came up with a similar idea that could be what day 2 is talking about in Genesis 1, but I won't get into that now. That process would mimic the action of dark energy, but that scenario violates, again, your Copernican principle, a notion near and dear to the hearts of physicists and cosmologists, including Caldwell and Stebbins, named after the 16th century astronomer Nicholas Copernicus, who made the then heretical, actually it wasn't heretical at the time, but it became heretical later, but we'll ignore that, who made the then heretical proposal that Earth does not have a favored central position in the solar system. The principle states that humans are not privileged observers in the universe, but have just as good or bad a vantage point as any other observer in the cosmos. Although the Copernican principle may be widely accepted by fiat, it's imperative that such a foundational principle be proven, Caldwell and Stebbins. So they basically say, the Copernican principle, we're all accepting it, but we don't actually know it's true. And if we throw that out and let the Earth be in kind of a special place, it would explain this. And again, these are not creationists that are saying this. So they're not going to be taken seriously because they've got to still hold on to this Big Bang model. And the Earth can't be special. We will not accept God. That's too hokey. Instead, we're going to believe in witchcraft without a witch. That's more respectable. You know, a modern, respectable superstition. You know, people have always been superstitious in the world. It just went under different names. This is the version that's popular today among your elites. Anyway, there's a lot more we can say about that. Summarizing the state of the Big Bang in light of the inflation problem. So in the midst of the fray back in 2014, when they thought they had found proof finally of inflation, Paul Steinhardt, who's a Princeton theoretical physicist and cosmologist, he initially actually helped to develop inflationary theory to try to fix the Big Bang. But now, to his credit, he's a scathing critic of inflation. And so he wrote this stinging critique of inflation that he actually helped make, and its alleged evidence from the gravitational waves they thought they had found. He argued that premature hype over gravitational waves highlights gaping holes in models for the origins and evolution of the universe. Okay, what are the gaping holes? He said the Bicep 2 incident, right? These guys thinking that they had found gravitational waves. has revealed a truth about inflationary theory. The common view is that it is a highly predictive theory. Let me talk about that for a minute. So if you've got a good scientific theory, you should be able to make predictions. We're not talking about predictive prophecy in the Bible. We're talking about let's say I make up a theory and I say, I think that there is an invisible force that draws smaller masses towards larger masses, kind of like a big magnet, and I'm going to call it gravity. Okay, so I should be able to make a prediction and say, if I'm right, then if I drop my remote, it should suck to the earth, right? And I can do an experiment that helps to validate my theory if I'm right. If I drop it and it doesn't stick to the earth, I've now falsified my theory, right? So a good theory is supposed to be able to make predictions. Okay, so he says the common view is that inflation is a highly predictive theory. If that was the case, and the detection of gravitational waves was the smoking gun proof of inflation, one would think that non-detection means that the theory fails, such is the nature of normal science. Yet some proponents of inflation who celebrated the Bicep 2 announcement already insist that the theory is equally valid whether or not gravitational waves are detected. How is this possible? The answer given by proponents is alarming. The inflationary paradigm is so flexible that it is immune to experimental and observational tests. The paradigm of inflation is unfalsifiable. It's clear that the inflationary paradigm is fundamentally untestable and hence scientifically meaningless. And that is the state of inflation and therefore the Big Bang, which needs inflation to fix its other problems. Now, the bulk of the scientific world around us believes it anyway. Who has the blind faith here? Not us. So problems like these have caused many cosmologists to start backing away and saying, I don't know about this Big Bang business. Back in 2004, okay, it's nearly 20 years ago now, New Scientist published a statement that was signed at the time by 33 scientists from 10 countries that had the guts to come out and say, we're backing off of this Big Bang thing. It's now, the list has grown to include hundreds of scientists. Now the statement that is being signed starts with these words: Big Bang theory relies on a growing number of hypothetical entities, things that we have never observed. Inflation, dark matter and dark energy are the most prominent. Without them, there would be fatal contradictions between the observations made by astronomers, the actual evidence, and the predictions of the Big Bang theory. In no other field of physics would this continual recourse to new hypothetical objects, right? They keep making up new stuff to try to fix every time they see something new, we'll just make up this over here to fix the problem so we can keep holding on to the Big Bang. In no other field of physics would this continual recourse to new hypothetical objects be accepted as a way of bridging the gap between theory and observation. In other words, the actual evidence. It would at the least raise serious questions about the validity of the underlying theory, but the Big Bang theory can't survive without these fudge factors. The Big Bang theory can boast of no quantitative predictions that have subsequently been validated by observations. Hypothetical, unobserved entities and objects, that's what the Big Bang is. And in other words, if you believe in this, it translates to no evidence, which is irrational. And the same thing goes for string theory and the multiverse, both of which also have no evidence for them. This isn't science. But it's nice to know that there are so many secular cosmologists that are, with some common sense, that are starting to come out there and acknowledge the truth, at least as long as there's some others that will stand with them, right? All right, of course, the most fundamental problem with the Big Bang or any naturalistic theory is a failure to account for the very beginning of things. So even if the Big Bang were true, it still doesn't answer where the universe came from, and that's the first plank on our evolutionary chart. Where do the laws come from, which we already looked at? The naturalistic evolutionist must believe that a law of science can create itself, even though there's no evidence that that can happen. Nobody has ever witnessed a universe growing laws of science, okay? And yet the naturalist must believe that can happen, as though that's some little thing. In other words, he has to have a blind faith in his model. But can the naturalist be a naturalist and still believe in things that don't happen in nature? See, I would argue there's really no such thing as a naturalist. We're all supernaturalists. We all have to believe something happened that was not natural. And they believe it too. They believe in a lot of those things. They just don't want to call themselves supernaturalists, but that's what they are. They believe in witchcraft without a witch. Now, another problem is, where did the stuff come from that banged in the Big Bang? Where did your cosmic egg come from, the ilum that started the whole process? So with the ilum in mind, let's look at 3 laws of science to see what they have to say about the origin of the stuff of the universe. Right? Remember to keep in mind these ideas about scientific laws. If anything can be said to be scientific, it would be the laws of science. Right? And evolution claims to be scientific. So if a theory contradicts the laws of science, then it can't be scientific, right? So first, the laws of thermodynamics. These are probably the most fundamental, sometimes they're called the super laws of the universe. And so let's go through these very meticulously and break this down. Make sure you understand the clear implications of these laws about evolution. The principles of thermodynamics have been in existence since the creation of the universe. One engineering textbook said, whether or not they meant to say that. The word thermodynamics stems from 2 Greek words, therme meaning heat, and so you'll recognize words like thermometer and thermostat and thermos. The second word, dunamis, meaning power, and so it describes the early efforts by engineers to convert heat into power or energy. And today, thermodynamics refers more broadly to the science dealing with all aspects of energy and energy transformation. Now, what in the world does that have to do with evolution? Well, let's stand back and think about this question of where the stuff came from of the universe. What are all the possibilities? Let's think through that without making any assumptions and just kind of reason through this. And so let's make it a little more tangible. Let's say you move into a new house and you climb up into the attic, and you see there a box, and it is completely sealed up. It doesn't even look like there is a seam on it. And yet you pick it up and you shake it and you realize there's something in there. There's a little ball in there. How did the ball get inside of this box that doesn't even have a seam? Okay, what are all the possibilities, even the crazy ones? Well, I mean, you got either someone put it there or no one put it there. Those are your 2 options. So either somebody did somehow open this box and put it in there even though you can't see the seam, or somebody maybe built the box around it, or nobody put it there. So it either created itself inside of the box, or it's always existed inside of the box. Those are your options. And that's the same options you have with regard to the universe. Where did the stuff of the universe come from? Now, the creationist model says someone put the universe here. The very first verse of the Bible, the creation model says, in the beginning, God opened up the box and put the stuff in there. Right? There's your creation model. So how would we describe that from a scientific perspective? So from a thermodynamic perspective, we would describe it this way. So imagine this box from your attic. I need to find a box that doesn't have a seam on there. That'd be a lot cooler. Anyway, just go with me for the illustration here. Imagine this box is big enough to fit the entire universe in it. Okay? So the box is the exterior boundary of the whole universe. Everything in the universe is in there. And so in that sense, it is a closed system, if you're using thermodynamic terminology. It means there's nothing going into the box from outside of the box because everything's already in there. And nothing's going out of the box because the box is big enough to hold everything in there. All right, so according to the creation model, before day 1, the box is empty. God essentially opens the box, creates the universe, puts it in the box, and then closes it and seals it so that nothing else could enter or leave the box. And so the box has remained closed since then, except at those times when God engaged in miraculous activity, where He puts the laws of science on hold, and then God does something that is not natural, that is above nature or super nature. So there's your creation model. Now the evolutionary model will again typically include some form of the Big Bang Theory. And steady state Big Bang Theory claims all of the stuff in the universe was originally crammed into this little speck, the size of a period on a piece of paper, this cosmic egg, and then that sphere basically exploded, hence your Big Bang, and then expansion and so forth over time until you have the universe as it is today. Now, again, this does not explain, though, where the little sphere, where the stuff came from that then exploded. So where could it have come from? Well, so even if you were to grant that the Big Bang actually happened, you still got to answer this question if you're a naturalist. So how did you get the ball in the box in the garage? Well, evolutionist Alan Guth is a cosmologist and physics professor at MIT, and he admitted this very point. He recognized that the Big Bang model tries to explain why the universe appears to be expanding, but it doesn't explain where the little ball originally came from. He said inflation itself takes a very small universe and produces from it a very big universe, but inflation by itself does not explain where that very small universe came from, all right? And so there's your problem. He says a proposal that the universe was created from empty space is no more fundamental than a proposal that the universe was spawned by a piece of rubber. It might be true, but one would still want to ask where the piece of rubber came from. So logically, you've got three options for where it could come from. The well-known philosopher from the 1800s, Herbert Spencer, he said, respecting the origin of the universe, three verbally intelligible suppositions may be made. We may assert that it is self-existent, all right, so it's eternal, it's always existed, or that it is self-created, so it somehow created itself. That's just such a silly thing to even say. I mean, because that is the dominant belief. The second one is the dominant belief. Or that it is created by an external agency. All right, so that's what reason and logic tell us. That's what you got. Immortal words of Sherlock Holmes, when you have eliminated the impossible, whatever remains, however improbable, must be the truth. All right, so which one is it? Spontaneous generation, eternality, or creation? If two of the possibilities can be shown to be scientifically impossible, the other alternative must be the truth. All right. So if you are a naturalist, then you've eliminated one of your options. So you got two possibilities. It's either self-created, all right, so it created itself. It is self-existent. It's one of those two. So if you believe in the spontaneous generation option, which is the idea that matter or energy just created itself, just popped into existence inside of the box, then in a thermodynamic sense, you believe that in the original box in the garage, it was complete, or in your attic, it was completely empty. So let's zoom inside of the box here. So the box is empty and no one put anything in there. And so you can just stand around inside of this box and stare into nothingness and just give it enough time. All of a sudden, something can just appear. And not only could something just pop into existence, but according to this version of the model, a little ball containing all of the matter and energy of the entire universe could just pop into existence. And then, so they say, the Big Bang process started. And then you have eventually, given enough time, life coming into existence and gradually evolving over time and turning into you. All right, so we got some major problems with that, even though that's the dominant belief. And the first one comes in the form of the first law of thermodynamics, which says energy can be neither created nor destroyed, but can only be converted from one form to another. And he's right, no argument there. That's what the first law tells us. Everything we've ever observed to happen in the universe is that energy cannot be created or destroyed. It just can change forms. And we also call this the law of conservation of matter and energy. So what does this mean practically speaking? Well, the first law says that in any process in the universe, like wood burning, you're at a campfire burning some wood, matter and energy can change into other forms while it's burning, like heat, light, smoke, ash, chemicals. But the sum total amount of energy in the universe that was present before you burned the wood has to equal the amount of energy in the universe after you burned it. So energy hasn't disappeared or been destroyed from the universe by burning the wood, and energy hasn't popped into existence in the process. It's just changed forms. So using more technical terminology, the first law would say that in a system, it can be in an open or a closed system, but we'll talk about it in a closed system because that's what we're talking about here. In a closed system like our box that contains the universe, so there's no energy coming into it or leaving it, the sum total amount of energy within the boundaries of that system must remain constant. So any process that you see, the amount that you have before, if it's zero, has to equal zero after any process, right? This is rocket science. It's really difficult here for you to get this concept. So if you start with nothing in the box before the stuff pops into existence, then what are you going to have in the box after? Nothing. Right. In other words, it doesn't matter how long you stare into empty space. A pew isn't going to pop into existence. And it's certainly not going to come to life and start strolling around. And it really doesn't matter how much time you wait. That's not going to happen. Now, you can believe in that. You just need to understand that's irrational. You have a blind faith. That's what you have to believe. Nothing is going to come into existence from nothing. Not something as complex as a molecule, much less all the other stuff of the universe. And definitely not a small sphere containing all of the energy of the universe. It's not going to happen according to the first law of thermodynamics, which, remember, has no exceptions. There's never been an exception to the law of witness, and so by implication it would be unscientific, it would go against the laws of science to believe that matter and energy could come into being in such a way that the first law of thermodynamics was violated. According to the first law, the only way that matter and energy can appear inside of that box is if it's caused to appear there by something outside of the box. That's what you learn from science. You don't have to see God to know from science that's got to be how it got here. That's what you learn. Now, evolutionists who believe in this idea admit there's no evidence for it. Atheist Victor Stenger is an evolutionary particle physicist and professor at the University of Colorado. He believes in the idea of spontaneous generation, but he actually came out and admit, I must admit that there are yet no empirical or observational tests that can be used to test the idea of an accidental origin. This isn't science. You know, part of their own definition of science is the ability to be able to do tests and observe this stuff. You mean the spontaneous generation of matter is a genuine blind faith? Now look, we again believe in the Christian system, but it's because it's based on evidence that substantiates it. It's not a blind faith. But if there's no scientific evidence for this idea, then how can it be considered to be scientific? There's no way to test it. It's a leap into the dark without evidence. I'm fixing to play another video here. Richard Dawkins, notice what he said here in a television interview 2012.
Of course it's counterintuitive that you can get something from nothing. Of course.
Let me start it again for you. You ready to roll? Here we go.
Of course it's counterintuitive that you can get something from nothing. Of course common sense doesn't allow you to get something from nothing. That's why it's interesting. It's got to be interesting in order to give rise to the universe at all. Something pretty mysterious had to give rise to the origin of the universe.
So do you see the pure blind faith here? I mean, he comes out and tells us, of course, it's counterintuitive, it's against common sense. Common sense doesn't allow you. Now that to him does not end the debate. That just means, it must be pretty mysterious because it did happen. That's what he says. Well, I'll give him it was something pretty mysterious. The word he's looking for is supernatural. And so I'll agree with him on that. But he's basically admitting all of the evidence, that's where your common sense and intuition comes from, says that can't happen, and yet he believes in it anyway. He has a pure blind faith. I would say you're right. You can't get something from nothing. Something mysterious did have to happen, and I know what it was. But he's got nothing. And yet he believes it anyway. Well, no wonder, some evolutionists do reject spontaneous generation. Robert Jastrow, famous evolutionary astronomer, notice what he said. The creation of matter out of nothing would violate a cherished concept in science, the principle of the conservation of matter and energy, or the first law of thermodynamics, which states that matter and energy can be neither created nor destroyed. Matter can be converted into energy and vice versa, but the total amount of all matter and energy in the universe must remain unchanged forever, and it is difficult to accept a theory that violates such a firmly established fact, he says. All right, so pretty straightforward there. Now someone says, oh, wait, what about quantum mechanics though? Doesn't quantum theory indicate that something can come from nothing? And so young people will hear somebody throw that out there, but you got to understand when you look into the details of what's going on, they talk about these quantum fluctuations that start with an energy field. So even if that could happen, which it couldn't, you have to still explain where the energy came from. So Stephen Hawking said, well, I'm not even going to get into this. You can read it in my book. I respond to it in the book. It's just the lengths to which these people will go to reject God is astonishing to me. In our last session tomorrow night, we're going to sum all of this up, and get to what is really going on here. And it's really, in a sense, the most important of the lessons, the very last one tomorrow. So be sure to be here for that. But according to the first law of thermodynamics, the energy has to be accounted for. They have no explanation for how it could come about in any natural way. It can't be created or destroyed in any natural process. So strictly according to the scientific evidence, specifically the first law of thermodynamics, the spontaneous generation of matter and energy could not happen. Now keep in mind, scientific laws have no exceptions, or by definition, they wouldn't be laws. These are regularities that apply in every scenario we've ever seen that we apply the law to. So in order for something to be a law, scientists have to have a lot of evidence and it never be contradicted. So notice, for example, what this textbook said about it. The basis of every law of nature, we're going to go through a few of them, is experimental evidence. And this is true also of the first law of thermodynamics. Many different experiments have been conducted on the first law, and every one thus far has verified it, either directly or indirectly. The first law has never been disproved. We can say that the second law of thermodynamics, again, like every other law of nature, rests on experimental evidence. Every relevant experiment that has been conducted, either directly or indirectly, verifies the second law, and no experiment has ever been conducted that contradicts the second law. The basis of the second law is therefore experimental evidence. So the evidence from science is that the laws of thermodynamics are immutable, they're unbreakable, and so we call them laws. So when the first law tells us the universe can't pop into existence from nothing, it means it. But again, the creation model, we don't have a problem with the first law of thermodynamics. The first law says that in nature, you don't see stuff creating itself. And if you believe in that, you're being irrational, you're being superstitious. You believe in superstitious mumbo jumbo, okay? The only way you can get energy into being in a system that didn't originally have it is if it is deposited there from something outside the system. In other words, a universal box that contains everything from the natural realm would have to be opened, and energy would have to be put in it from something outside of nature, supernature, which is exactly what we would say happened. Of course, you read about it in Genesis 1, about how that happens, and then Genesis 2, 1 and 2 tells you, thus the heavens and the earth and all the host of them were finished. And on the seventh day, God ended his work which he had done. So in keeping with the first law, matter didn't create itself. It was put here by something outside of the box. And then after it was created, he shut the box. In other words, he rested. He ended his work. Nothing else is coming into existence in that box. And that is a summary of the first law of thermodynamics, which, keep in mind, was 3,500 years ago. Isn't it amazing that scientists didn't formally state the first law until the 1800s, and yet God had already laid out the thrust of that thousands of years ago? We could make a prediction about the first law of thermodynamics thousands of years ago before it had even been discovered, based on the Bible. The creation model is in perfect harmony with science, with the first law of thermodynamics, unlike the evolutionary model. So what about the other option? Could matter have existed forever? Now, most cosmologists used to believe this, but it's fallen on hard times because of the implications of the second law, which we're going to talk about now. But for the sake of being thorough, let's go ahead and deal with it as well. So the eternality model would claim the universe has always been inside of the box. No one put it there and it didn't pop into existence. It's always been there. So it's either been moving through space forever, expanding, or if you believe in the oscillating universe model, you believe the universe operates in a cycle where you have a collapse and then another big bang and then expansion and a collapse, another big bang, expansion, repeating like a big accordion forever. But this model would say that matter and energy are therefore eternal. The universal stuff has always been here. But again, you got major problems in light of the scientific evidence. The first is what's called Olber's paradox. Olber highlighted the fact that the more distant a star is, okay, distant star brightness decreases. Okay, so the farther a star is, the less bright it is. But the number of stars visible increases with distance. So when you put those two things together, it leaves us with a prediction. If the universe is infinite in size and age, with the stars uniformly spread out through the universe, as the Big Bang would suggest, then the entire sky should be filled with starlight. So that to us, the sky would be as bright as the sun at all times in every direction when you look into space. Obviously, that's not the case, thankfully. The second major problem is the second law of thermodynamics, which Paul Davies accurately said. The celebrated second law of thermodynamics says, roughly speaking, that in any change, the universe becomes a slightly more disorderly place. The entropy goes up, the information content goes down. This natural tendency towards disintegration and chaos is evident all around us. We can see that all around us. It's clear. All right, so returning to our wood burning example, when all of that wood burns, all of the energy that was present before it burned is still present after it burned, according to the what? First law. But according to the second law, much of it has transformed into a less usable form of energy, like heat. And when that heat dissipates, you're essentially left with a pile of ash, which isn't nearly as usable. So everything's breaking down, deteriorating in that way. So in a technical sense, the second law builds on the first. And again, it says that even though you've got the same amount of energy present before and after a process, again, you lose some of it. Well, you don't lose it, but it becomes less usable. You lose some of your usable energy. The total amount of energy is the same, but it's now becoming in a less usable form. Now, what that means, practically speaking, is everything is wearing out. The whole universe is, and in other words, nothing lasts forever. And like Paul Davies said, you can see that idea everywhere, can't you? Wouldn't it be nice if your car got nicer over time? You go to a junkyard and you get a clunker, and just watch it. Eventually, it'll turn into a Ferrari. Just give it enough time, right? Well, we've got a law that says that's not going to happen. It's going to go the opposite direction. Kids, wouldn't it be nice if your room would just clean itself on its own, or your house wouldn't eventually fall down because of entropy? Well, that's what the law says. This is the rule, which, by the way, why does the rule do that? That's another one of their dilemmas. These laws come into existence, and why do they do what they do? I read lots of papers where they're trying to figure that out. Why does it go that way instead of going the opposite way? Why does the law do that? They don't know. They don't have any idea. It all makes sense in a biblical perspective, but they don't have an explanation for it. And again, just like with the first law, the second law has no exceptions. To date, no experiment has been conducted that contradicts the second law, and this should be taken as sufficient proof of its validity, if you're being rational, of course. So, what does this mean concerning the origins question? What's the implication? Well, it means the universe couldn't have always existed, and we still have usable energy. So according to the second law of thermodynamics, if the universe is infinite in age, then we should be totally broken down. We should be at heat death, thermal equilibrium at zero, okay? No movement going on anyway. So the universe would be completely worn out. And yet we have an abundant amount of usable energy, in harmony again with the creation model, which would say the universe is only a few thousand years old. Now, again, most people don't even accept this idea of the eternality of the universe anymore, but it'll probably pendulum back to it in the future. But remember, Robert Jastrow of NASA, considered one of the greatest science writers of our age. He said, and concurrently, there was a great deal of discussion about the fact that the second law of thermodynamics applied to the cosmos indicates the universe is running down like a clock. If it's running down, there must have been a time when it was fully wound up. Modern science denies an eternal existence of the universe. He said, now 3 lines of evidence, the motions of the galaxies, the laws of thermodynamics, the life story of the stars, pointed to one conclusion. All indicated that the universe had a beginning. Kitty Ferguson, an award-winning science writer and evolutionist, agreed. She said, it's also common knowledge that the universe isn't eternal, but had a beginning. So many in evolutionary circles realize that conclusion. Now notice what Stevie Hawking said. Here's what he said about the eternal universe idea. Hang on one second. I have a freeze up. It's a good point. It's a great point. It does not like that slide. Probably because it's such a powerful quote. That's what it is. All right, here we go. So here's what Stevie Hawking said. There must have been a beginning. Otherwise, the universe would be in a state of complete disorder by now, and everything would be at the same temperature. In an infinite and everlasting universe, every line of sight would end on the surface of a star. This would mean that the night sky would have been as bright as the surface of the sun. That's what I was talking about with the Olbers paradise. So he, of course, again, did not accept the idea of an eternal universe. Well, so there's quibbles to these. Again, I go through all this in my book, but somebody says, yeah, but couldn't there have been an exception to the laws of thermodynamics at some point in the past that would allow us to get past this issue? I mean, that's what they have to say. But again, according to the definition of a scientific law, it doesn't have exceptions. It's not that there could be an exception. No, it's that if you want to be rational, you have to draw a conclusion that is demanded by the evidence. So you can't say, well, I got all this evidence that demands this, but I'm just going to ignore it, or you're being irrational. So the question isn't whether there could be exceptions. The question is, should you believe in an exception when you have all of this evidence that says that there aren't any? That's the question. So to claim that there's some unknown exceptions would be to claim something that goes against the evidence. Now, a perpetual motion machine is a design that attempts to violate the first or the second laws of thermodynamics. It tries to find an exception. And numerous attempts have been made to try to design something like that, all without success, right? If a person could do that, they'd be in great shape. But these machines are not possible. And even the government of the United States understands that, whether or not they fully grasp the implications of it. The laws of thermodynamics have been substantiated to the point that in 1918, the U.S. Patent Office declared they would no longer even accept patent applications for supposed perpetual motion machines. They were tired of getting applications for these impossible devices that all ultimately ended up violating the first or the second laws of thermodynamics. They recognized these attempts as pointless. But as Philip Yam said, writing in Scientific American, claims for perpetual motion machines and other free energy devices still persist, of course, even though they inevitably turn out to violate at least one law of thermodynamics. So there's just no exceptions to these laws. Now, if you develop a theory that requires that the laws of thermodynamics are broken, that's unscientific. If you develop a theory that sets the universe up as a perpetual motion machine, being able to last forever, in defiance of the second law of thermodynamics, that's unscientific. And it's irrational, and it doesn't matter how much jargon you throw into the air to confuse people. If you believe in something like that, it amounts to irrationally drawing conclusions that are not warranted by the evidence, all of which points to the idea that nothing lasts forever. And guess what already predicted that that would be the case? Hebrews chapter 1, this is quoting Psalm 102, which goes back 3,000 years. You, Lord, in the beginning laid the foundation of the earth, the heavens are the work of your hands. They will perish, but you remain. Notice, they will all grow old like a garment. Like a cloak, you'll fold them up and they'll be changed, but you are the same and your years will not fail. God, of course, is different, but the universe is going to grow old like a garment. But He has eternal power. Right? Romans 1:20. So God will exist forever. He's got eternal power, but that's not the universe. All right. So, what does the evidence indicate? You've got three options: creation, spontaneous generation, or eternality of matter and energy. By definition, the laws of science do not have exceptions. The laws of science prohibit the only possible naturalistic evolutionary models, while the biblical creation model is in perfect harmony with those laws and even predicts their effects based on what Scripture teaches. So, the logical conclusion from the evidence: creation is scientific because it does not violate the laws of science. It is rational because it is a conclusion that is demanded by the evidence. And it's the only possible choice once you eliminate the other two options. So by implication, there has to be a God. And you don't have to see Him to logically know there has to be. The evidence demands it. All right, one other law of science we'll plow through here real quick that stands against this model, the evolutionary model, is the law of cause and effect, or the law of causality. So if you got an effect, there must logically be a cause, right? This is real complicated stuff here. Now, more precisely, every material effect must have an adequate antecedent or simultaneous cause. So every effect we've seen in the physical universe has to have a cause that is adequate, so it's strong enough to cause the effect, and it has to be antecedent, so it has to come before the effect, or it can be simultaneous with the effect. Okay, that is what all of the evidence has said. Now, this law is so obvious that it's kind of taken for granted. It's just assumed. But you can't really just brush this aside without consideration when you're talking about the origin of the universe. The whole goal of scientific experimentation is to figure out what will happen, what will be the effect if you do certain things, if you initiate certain causes. Now, if there's no relationship, you can't do science. There'd be no such thing. This is fundamental. What science is all about is cause and effect. So if there was no relationship, today, there's gravity, but tomorrow you wake up and you're just kind of floating up off of your bed, and there'd be no such thing as a regularity, because that's what laws are. Things would just be random and chaotic, which is what you'd expect if a Big Bang made everything. But you can't do science if that's true. Notice what the National Academy of Science said about this. Remember about causality. One goal of science is to understand nature. Understanding in science means relating one natural phenomenon to another and recognizing the causes and effects of phenomena. This is fundamental to science, causality. Okay, so if a baseball comes flying over the fence in your backyard, you know there's a cause for that, right? Did it just start flying into your backyard, break your window on its own? Maybe it did. Okay, so leaning against a mountain is not going to cause it to topple, because that is not an adequate cause, right? Okay, if you're sitting in a room and a wind-up toy comes strolling across the floor in front of you, you know that someone wound that toy up and sent it running, right? If you open up the cookie jar and you see a half-eaten cookie, right? And there are children in the house, or I'm in the house, then you know what happened. The cookie certainly didn't eat itself, yes, in theory. For some reason my computer's starting to kind of panic here. It's saying, look, I'm tired. You've been up since 3:30. Go to sleep. Okay, so how about the pyramids? Wait, what did it say? Wait. I can't read what it says. Let's bring it over here. All right, here's what we're going to do. We're going to shut down this. Try it again. All right. Let's see if it works better with a reboot like that. Here it is. All right, let's see here. Cross your fingers there, buddy. Entropy is in effect here. All right. Pyramids of Giza, one of the 7 wonders of the ancient world. The world can't come to an agreement as to how these great structures were built and why. Anybody see the movie Stargate back in, what was it, like the 90s or something? You remember what they said about the pyramids? That aliens had to do with it. So, I mean, there's all this debate about these because they're just so amazing. But you know what? Nobody is saying they built themselves. Even though nobody was there, they don't know how these were built. But nobody's making that claim. Intelligent design was involved. Stonehenge, these are even less sophisticated. And yet scientists have figured out that these formations apparently were designed to allow predictions based on the stars and so forth. But they got all these questions like, how they use this info, how did they get the rocks transported there and set up just right. But again, one thing is clear, even though they weren't there to witness the creation of these formations, an adequate cause is necessary, and nobody is silly enough to say that it was some tornado ripping through a mountain nearby making these. Even though they weren't there to see it, they recognize the design demands a designer. Apparently, common sense doesn't have a place in a discussion of origins today, is the issue. Because we know that in nature, an effect has a cause. The planets exist, that's an effect. They're moving through space, they're spinning, these are effects. The existence of life, where you have living stuff, that's an effect. It demands an adequate cause. Someone has to cause these things. They can't happen on their own. Logically, that's not an adequate cause. So that said, the evolutionist is in a fix on this, because you've got this infinitely complex universe. How can that come about without a cause? Some 4 decades ago, Robert Jastrow of NASA, who I quoted from earlier, he said, the universe and everything that has happened in it since the beginning of time are a grand effect without a known cause. An effect without a cause? That's not the world of science. It's a world of witchcraft, of wild events, and the whims of demons, a medieval world that science has tried to banish. As scientists, what are we to make of this picture? I do not know. Now, of course, when he says there's no known cause for everything in the universe, he's talking about the fact that there's no known natural cause. Because if they're right, there has to be a natural explanation, but they've got nothing. Scientists and philosophers recognize there has to be a cause that would be adequate enough to bring about the universe. So they understand that the law of causality applies. Again, the creation model doesn't have this quandary. We know exactly what the original cause is. And God's the one that tells you right off the bat how this happened. Hebrews 3:4, every house is built by someone, duh, but he who built all things is God, the ultimate cause of all things. So, of course, the big question everybody says, oh, well, wait a minute. Now, if everything has a cause, then why doesn't God have a cause? And first of all, keep in mind this statement, everything has a cause, is not what the law of causality says. Every material effect must have an adequate cause. We've only witnessed the material realm. We don't know anything about the supernatural realm. We can't observe that. God is not material. He's spiritual, John 4:24. So the laws of science can only apply to the universe. They don't apply there. But second of all, let's just go ahead and think through the logic. Let's say that the laws did apply in the supernatural realm. Let's reason through that, okay? Okay, so if there was ever a time in history when absolutely nothing existed, not even anything spiritual in the supernatural realm, then nothing would still exist, because you're now taking the first law of thermodynamics and the law of causality and using them in the supernatural realm now. All right, and things don't create themselves. Since something exists, we know the universe exists, that means that something had to exist forever. Right, logically. But we know it can't be physical because of the second law of thermodynamics. So logically, there has to be a cause that is uncaused, that existed forever. That's what logic tells us. So there's no quandary here for the creationists, but you've got a big problem if you say there's nothing outside of the box and you want to try to explain everything without supernature. Now you got a major problem. So revisiting our origin model comparison chart. Remember, if only one of these planks is shown to be wrong, the whole model collapses. And we've seen the universe could not have created itself and it couldn't have existed forever. The law of causality adds even more evidence. The universe couldn't have caused itself, and that also implies life couldn't have created itself, because life requires an adequate cause too. The evolutionary model has no answer to that question. We'll talk about that tomorrow. But again, the creation model is in perfect harmony with the laws of science in all these areas. The creation model argues, in keeping with the laws of thermodynamics and the law of causality, that matter and energy and life were created by this being outside of the box. That's not subject to its laws. He created the laws. So if one were to stand back at this point and assess which model fits the evidence, which is the rational choice, which would it be? I mean, look, I'm just trying to follow the evidence here. I wish I could get the naturalistic community to do that. God himself wrote the natural laws into existence, which govern or have dominion over the earth. God alone is capable of that. Laws certainly can't write themselves. The atheist can't explain their origin. And the consistent message that is implied by these laws that keeps shouting out to anybody that's willing to listen is that there has to be a God out there. That's what science actually tells us. All right. Let me highlight a few things for you as we close here. Remember, we need to be ready to contend earnestly for the faith in this crazy day we live in. Reason Revelation has been our monthly journal that we've had on Christian evidences for, I've lost track, probably over 40 years now. This, for basically $1.25 a month, keeps you up to date on the latest things that we're studying that we think you need to know about as Christian apologists. There are three fundamental pillars that undergird the Christian faith, which have been totally eroded in our society. It's the existence of God, the inspiration of the Bible, and then the deity of Christ. So these three books are designed to show you the evidence for those three pillars. So very important books. These are our adult level books, so there's a lot of material in there, a lot of information to be able to substantiate those truths. The anvil rings, one of the biggest arguments atheists will try to use against Bible believers. They'll come at you and say, you can't believe the Bible. The Bible's not reliable. It contradicts itself all over the place. And then they'll spew off 10 or 15 alleged contradictions. And it's intimidating because you're thinking, man, even if only one, and they all seem kind of legitimate on the surface, and you're thinking, even if only one of them sticks, then the Bible's not inspired. And so this is one of their biggest tactics they're using to make kids fall away. So these books are written to show you that those arguments don't hold water. The Bible doesn't have contradictions. That's silliness. There's actually 3 in this series. We just released the 3rd one. Truth About Human Origins is a pretty thick book on that question, dealing with the alleged evolution of humans. Christian's Guide to Refuting Modern Atheism is Kyle Butt, who works with us at AP. He debated Dan Barker back in 2009, and Dan Barker the one good thing he did was he did a good job of, I think, making the case for atheism the best it can be made against the biblical model. And he made a lot of really good points against the biblical model that we need to be ready to deal with. And so this book kind of equips Christians with the arguments that atheists are trying to use to disprove the Bible. And again, especially thinking about our young people, they're hearing that garbage and it's destroying their faith, not knowing that there's obvious, legitimate answers to these supposed problems. Surveying the Evidence is our flagship book for adults on Christian evidences. The Dinosaur Delusion explores evidence that shows that humans and dinosaurs did in fact coexist, since we're both created on the 6th literal day of creation. You know that dinosaurs and humans are on the land, on the earth at the same time. So that explores that evidence. This is probably the number one argument people have tried to use against the God of the Bible, and that is, how can you have a God that is all-loving if innocent people and the good people suffer? Okay, so either God's not all-loving or He's not powerful enough to stop suffering. And so the point of this book is to get into, how does the Bible answer that question? The Bible has a lot to say on that. So think in terms of not just yourself on this book, but think about other people you know who are going through suffering and might be questioning God right now. You know, this is the kind of book that Job's wife needed to read, right, with what she went through. And Job needed to go through it too. And in fact, the book of Job gives us a lot of information about what's going on there. So that is the point of that book. Science vs. Evolution, that's the book that is really for this seminar. Is Christianity logical? Again, most people argue that Christianity is more an emotional, touchy-feely religion that's not based on the facts. And that is not what you find when you go into the Bible itself. You find logical argumentation all over the place, where God is clearly all about presenting evidence and forcing people to logically arrive at conclusions. It's not touchy-feely stuff that can't be proved. Here's another book on the inspiration of the Bible that goes into other proofs that the other one that's kind of our main inspiration book doesn't go through. Behemoth and Leviathan, going through those amazing creatures that God talks about in Job 40 and 41. The Anvil Rings, this is the 3rd volume I told you that we have in that series. Another book, this is on the inspiration of the Bible, specifically with regard to this one interesting prophecy in the Old Testament that we see come to fruition in the New Testament. Scientists speak out about God and evolution. This is an interesting book. It's the scientists that have written for AP over the years. It is pulling together a lot of those articles that we have written on the topic of God and evolution and showing you. It's a powerful book because it's all these different scientists speaking out on this subject. Whenever I was doing a culture war seminar in Tennessee a few years ago, one of the points I made was that, our brethren need to get busy. We got to be doing something. We can't be sitting around and if, we sit around and complain about how bad the world's getting, but then we do very little to do anything about it. And at the very least, we could be leaving tracts all over the place. We go eat somewhere, go to a hotel, just leave a tract there. A gas station, leave it on the pump. It's the least thing. So a guy came up to me and said, hey, that's a good idea, but what kind of tracts should we leave? Because so many of our tracts are very specific about, odd things that would be interesting to brethren, but they're not the kind of thing that you would necessarily leave in a restaurant or something. And so we developed this line of tracts that is about the fundamentals. Existence of God, inspiration of the Bible, deity of Christ. Has the Bible been corrupted? And that's the point of it, is to hit these very fundamental issues that wouldn't it be nice if everybody in Oklahoma City had seen some evidence on those topics, these fundamental things. And so we developed those and then took the three main ones, the three pillars, and put them together into this book, along with a book on how to become a Christian, which you can use as an evangelism tool to hand out to people. So congregations will buy these entire boxes of these so people can hand them out. We've got other in-depth type tracts that are available as well on some fun subjects. Also a lot of culture war stuff that's not really Christian evidence-y, but is more dealing with things that have come out of our increasingly pluralistic, anti-God, humanistic, evolutionary society. Dealing with environmentalism, sexual anarchy is the dealing with homosexuality and abortion and so forth. The Quran, Islam is growing by leaps and bounds in our own country. So looking into that to determine how you can know that it is not inspired. What the founders actually believed compared to what revisionist history has said about them. This is a fascinating book that I think every young person needs before they go to college. And it's answering the question, at least I describe it this way. If you wanted to create your own government, what is the best way to know that your government will be most effective kind of government? Well, obviously, if God said anything about it, then that's going to make the best government, right? So did God ever have anything to say or create a government? Yes. The Hebrew code was a government code. So if you strip it of the more specific, more religious aspects, you're left with this framework for what God would say about taxation and punishment and immigration and what your leaders should be like, all kinds of things. It was an amazing study when my dad went through that. But he's able to tie in and show you that's exactly what the founders of our country were trying to do. And he documents that that's what they were trying to do. They were trying to set up our government to be that. So fascinating book. And again, think about young people, the kind of stuff they've been taught in school and what they'll be taught in college that is going to turn them into a bunch of socialists and communists, which is unbiblical concepts. So check that book out for them. Fake Founding Fathers Quotes, which is going back and looking at the actual primary documents, responding to supposed lies that have been said about the founders. My wife and I wrote a 2-volume set on what the Bible says, not what Julie and I say, but what the Bible says about the subject of child rearing, because I just hadn't really seen a lot on that. Homosexuality, Dad and I co-authored that book, looking at the science and psychology and what Scripture has to say about that important subject. Here's the second volume in that. Also have a lot of brotherhood, church-oriented things, apologetics in the church, what the Bible says about these various religious groups. This is on the principle of authority, instrumental music, the principle or how to become a Christian. This is an important book I would recommend for every new convert So imagine somebody becoming a Christian, he gets baptized, and you say, all right, good luck to you. You need to be sure to read your Bible. And he goes and sits down and starts trying to read his Bible. And he gets through Genesis all right, and Exodus starts getting a little difficult. And he gets to Leviticus. What in the world's going on here? And he gets to Deuteronomy. What? Okay, I give up. Maybe he skips over to the prophets, Jeremiah. Or he jumps over the New Testament, tries to read Hebrews. The point of this book is to give you 1 or 2 page summary on every book of the Bible. What is this book about? What's the context here? Is there a thematic verse to kind of keep clear as you're studying this book? So great book to hand, just a little booklet that you can hand to new Christians to kind of give them a little bit of perspective as they start studying. And I developed this little booklet, especially with teens in mind, that highlights for them what are the responsibilities of a Christian. How do you properly interpret the Bible as you're reading the Bible? What are the principles to make sure you're getting the proper interpretation? What are some of the materials you need to start getting in your library for when you have questions that you need answers to? This is a book Dad wrote on, which by the way, my dad is Dave Miller, who's the director at AP. That's who that is. I keep name dropping him. So baptism in the Greek made simple. So this gets into the Greek of how conclusive the Greek makes this question of the essentiality of baptism. It just cannot be denied. But he makes it in a simple way where the layman Christian can get it. He's also got a book on female leadership in the church and the question of lifting up hands, which is becoming more prominent, coming out of the denominational world. What the Bible says about the Mormon church, modern day miracles he just put out in the last year or two. Of course, there's big groups of denominational people that believe that miracles happen today, so it's looking at that topic. This is another fascinating book going into some of the background things that'll help you to understand the Bible better, things that relate maybe to language or culture that'll help to explain things as you read them. This one here just came out in the last maybe month over the question of the end times, dealing with premillennialism, which a huge percentage of the denominational world around us does not have clarity on. Our study Bible, of course, very popular. This takes basically hundreds of our articles and puts them in a summarized form in the relevant places in the Bible where they should go, including a compendium of all the alleged discrepancies and contradictions that people claim are in the Bible. And so this is another one of these things, a tool that you want graduates to be sure to have before they go off to college. And we've got different varieties of those in colors and whether it's leather or not, and all, different varieties you can get. All right. So we've now gone through the laws of thermodynamics and the law of causality. So tomorrow we're going to start digging more specifically into Darwin's evolution and some of the issues with that. The subject really is already dealt with, but we're going to systematically deal with this. So I encourage you to be here tomorrow for that, and be sure to again get some good rest on this because there's going to be a lot of material to cover tomorrow. All right, thank you very much for your attention. Do you have anything to add to this, Dylan?